This is J.C. De La Garza. I'm with the Office of Used Nuclear Fuel Disposition here in, I'm the federal point of contact for the Irp Fc1 sensors and delivery devices for dry storage of used nuclear fuel. Chart 2, please. Chart 2, please. There we go. The U.S. commercial nuclear power industry is quite diverse, with power stations located inland and on seaboards. Nearly all plant operators are moving used nuclear fuel from wet to dry storage and have been doing so since 1986. It appears likely used fuel will remain in dry storage for several more decades. It is important that the health of dry storage systems be confirmed and maintained. This IRP focuses on the development of methodologies that can help industry and DOE resolve potential technical issues associated with dry storage of used fuel. Chart 3, please. While other projects have focused only on instrumentation development and monitoring system, this IRP focuses on developing new sensors for difficult locations and the associated delivery of these tools to dry storage systems. There are many challenges associated with this. First, there are several dry storage systems in use today, and there are several variants depending upon a utility's specific needs. The dry storage systems are located at ISFCs and are highly secure. However, the used fuel stored in these systems present radiological and safety hazards as well. Chart 4, please. Work to be performed. Considering these challenges, the research needs of this IRP must include all of the following: innovative approaches for acquiring samples. Innovative approaches for acquiring samples from the surfaces of used nuclear fuel dry storage system components, such as the concrete overpack and used fuel canisters, are needed. Sampling approaches should consider access into the dry storage systems, how to gain access into the dry storage systems, including inside concrete overpacks, to access used fuel canisters, where used are used. Remotely operated systems requiring minimal or preferably no human interaction are of interest. Sensor development for access into dry storage systems. Although many sensors exist, some of the sensors may need to be smaller and more accurate for placement inside high radiation conditions and in areas that are not easily reachable. Surface sample collection. A system must be developed to acquire surface dust and deposits that accumulate on the surface of the dry storage system components. All of the following parameters need to be analyzed. The analysis could be done by having a system to gather the samples and delivering them to the outside for analysis, or developing remote sensors to analyze these parameters in place. The items to be analyzed by collecting samples or remote sensors include deliquescent salts, organic and inorganic matter such as microbes, pollen, dirt, clay, etc., chemical signatures of potential reactions, for example, microbial corrosion or other chemical reactions, concrete degradation products, and performance of radiological surveys to determine integrity of seals and welds. Inspecting dry storage systems. Innovative approaches for inspecting dry storage system components are of interest, including inspection of difficult-to-access locations, such as the base of canisters inside storage overpacks or along rails used to support canisters in horizontal systems. Characterization/inspection of canister welds and other welds. Inspection of bolts and seals where used. Characterization/inspection of potential cracks in concrete for those systems with exposed concrete. Determination of the presence of water, that is, inspection for water staining or pooling. Measurement of surface temperatures, visual inspection of surfaces, and documentation of the locations of samples and inspections to allow reinspection in the future. Chart 5, please. Remote sample analysis. Innovative approaches to perform sample analysis remotely are of interest. Analyzing samples in situ reduces the need for radiological surveys to release samples for analysis outside of the ISFC, and it allows more data to be taken. Integration of the delivery system with sampling and analysis is desired. Deployment of existing instruments, sensors, detectors, as well as novel approaches is desired. Data collection. Innovative approaches to data collection, management, and storage. It is anticipated that a data gathering device could accumulate hundreds to thousands of individual data and samples in varying formats, such as videos, spectroscopic, elemental, solids, etc. Data quality must be ensured and protected, particularly in a challenging environment that includes heat and radiation. Cybersecurity. Cybersecurity is an important consideration while working inside a utility's ISFC, and creative solutions for potential transmission of data from a highly secure environment is also sought. Systems performance. A successful project will develop the following: a system where all of the features discussed or analyzed can be evaluated through at least one delivery or analysis system prototype for testing and evaluation in mock-ups of different used fuel dry storage systems. While it may be possible for one device to be deployed on multiple dry storage systems, it is acceptable to develop system-specific devices. The proposed approach to be taken should be documented in the proposal. If sensors are proposed to be used to generate the desired data, they should be developed to analyze the materials in place and transmit the data so it can be collected outside the cask. Chart 6, please. Stand by. Deliverables. Alternatives analysis. Because of the variability of solutions that can be used, within 6 months after award, a progress report shall be submitted to the DOE discussing how the data required above will be collected. Progress report. 18 months into the project, a progress report shall be submitted to the DOE that discusses the technical progress made towards solving the issues described above. And a final report. 36 months into the project, a report shall be submitted to the DOE that discusses the technologies developed and how they can be effectively implemented. That concludes the presentation portion, and I'd be happy to try to answer any questions that you might have on this IRP.
JC, maybe we can go back to the previous question that we had.
Very good.
To the previous work scope. It states, for the transportation task, are advanced modeling approaches focused on failure modes, i.e. barriers, or on consequences, i.e. atmospheric dispersal?
All of that, the short answer is it's not an or, it's a yes to both. There has been research done regarding consequences to air dispersal and that sort of thing into the environment in the event of a transportation accident. The research has been done in both areas, and it would be up to the proposer to do some background research to see what information is already out there, is already available, so that work is not duplicated. Because one of the things that we will be doing when we receive proposals is doing a search to see what degree of information has been developed previously. But it's not one or the other. It's both that are open fields.
Okay, next question. This is for the IRP. What is the temperature range for the fuel and the cast?
The temperature range for the fuel and the casks? We are looking at, I'll answer that question in terms of hot fuel that has been recently taken out of wet storage and moved to relatively hot, that has been taken out of wet storage and moved to concrete overpacks, to fuel that has been in storage overpacks for an extended period of time, and that would cover the gamut, I would think, from 5-year-old fuel, something very new, to fuel that has been in storage for quite some time. So rather than go to specific temperatures, I would offer that it be a time consideration, that we would go from recently moved fuel to fuel that has been in storage for an extended period of time, and what the condition of those storage facilities might be for over the long term, and then again some that have already been in storage for an extended period of time, and what the condition of those storage facilities might be.